The challenges within a confined space are dark areas, the chemicals that were inside that confined space, lack of oxygen, movement.
It's not a nice place to work in a tank. You're being sandblasted and it's really dark and dusty and very uncomfortable with all the gear on, and there can be gases in the environment.
So we understand the danger of working within confined spaces. The safety of our crew is at risk the majority of the time. Our solution is the Alpha 1 and Track 1 systems.
Confined SpaceRobotics is a Canadian-owned company. Our specialty is working with robots to go into confined spaces to perform the dangerous work within tanks and pressure vessels and other areas.
Traditionally, you would have to wear protective clothing, breathing apparatus to completely cover the face and secure you against those types of gases that can really be not just harmful, but actually deadly.
We've worked within 30 different pressure vessels up to date. The arm performs about 95% of the full sandblasting portion, while humans perform balance of the 5%.
This is really the wow factor, is that nobody has it in the world, and we're the only company that can go out in the field and get the job done as of today.
We've effectively reduced human exposure to dangers in confined spaces by 90% during an entire mission. But it's actually 100% elimination during dangerous operations, such as blasting and coding. There are no personnel within those spaces during those dangerous operations. The Confined SpaceRobotics technology roadmap consists of 4 discrete phases. The first one is commercialize, then mobilize, automate, and finally complete autonomy. We are working to eliminate the confined space entries and to improve the quality and efficiency of asset renewal tasks.
The robot can blast in a straight line, whereas anyone else can't. The quality of work improves tremendously. We went to the field where we had one wall done by human and another by the robot. It looks like child's graffiti versus something that's almost silky smooth.
We actually can achieve an SP5, white metal profile, and we can do that 24 hours a day, 7 days a week.
Where humans over time do get tired from the morning work shift to the afternoon work shift. Or if men and women have been moved from day shift to night shift, they're naturally more tired in that cross shift. A robot won't know the difference. It repeats itself repetitively the same from morning to night.
There's a speed component in the oil and gas industry. With the Alpha 1 system, it doesn't stop. It can run all day, all night. It doesn't need any breaks, as long as you can keep up with it.
Robotic technology doesn't necessarily reduce jobs. What it actually does is create opportunities for new types of jobs. To operate a system like this, we need trained technicians, very much like we need a sandblaster to go in. Instead of having that sandblaster personnel, we would instead have an operator.
The programs and the processes with these robots are not overly complicated. For us to train users to use the robots, that's an easy process. This will be able to train almost any employee to perform the work. The operator just has to push a button, and the rest of it is performed autonomously by the robot.
The operator control panel shows the operator the exact positioning of not only the asset that the robot is working in, but also the robot itself. So you can very effectively see what is happening on the screen in a virtual way without being present.
At the end of the arm, there's a sensor that will scan its surroundings for any obstacles and orient itself. And it does it with precision. The robot will analyze the data, will figure out the best path to follow to perform that task as quickly as possible without missing any spots. It has 6 degrees of freedom, which means it can rotate in 6 different axes to be able to reach those hard to get places a little bit more than what a human can do without moving from its position. The Alpha 1-SB is great for sandblasting. The Alpha 1-CA is our coating applicator.
We can very quickly swap out the sandblaster end effector for the coatings applicator end effector. And in fact, swapping those tools out on the end of the arm would probably literally take about 10 seconds. Track 1 is a remotely controlled platform. We're developing it to carry different tools. Currently, we're using it to vacuum up debris within the assets after sandblasting. And we have also begun testing it with the Alpha 1 arms, the sandblasting arm, SB, and the coatings applicator, CA.
The Track 1 system was designed from the ground up, and it's vacuuming while the Alpha 1-SB is blasting. Since there's no human in the confined space, we can run 2 robots, 3 robots at the same time.
The back end of the vacuum system is the same as traditional system, a vacuum truck with the quick cam connectors. That will go to the back of Track 1 and it will connect to the nozzles on Track 1 for vacuuming.
At present, our robot arm can reach 100% of the inside of confined spaces. We use scaffolding or other lifting devices to move the robotic arm up and down. Our goal is to eliminate that using magnetic crawlers or crawlers that have suction cups on them to move the robotic arms up and down within the vessels to reach 100% of the confined space.
Some of the challenges that we've overcome already have come with operating in the field. It's one thing to set up the equipment and test it at your own facility and under your own conditions and everything is controlled, but when you get out to the field and you start trying to set this up in situ at a customer's site, everything is different, and so you have to be able to adapt to all of these differences, find ways to get the job done. Some of the big challenges have been actually getting the equipment installed into the tanks that we've operated in.
How do you pass the cords through? You look at the system, you don't really think about all these things. You realize that there's challenges everywhere you look. Our end goal is for the robot to drive itself inside the confined space, blast or perform the task, and exit without anyone entering the confined space.
The team here at Confined SpaceRobotics is very strong, actually. There's a lot of depth in a number of different disciplines. We've been able to actually work very well together, and I think that's a key to any team.
I'm really excited to see this technology move ahead, and we want to be able to be the leader within this confined space and move this technology around the world.
Some of the tools that will be available for the multi-tool platform will be a holiday detector for identifying thin coating areas that need to be repaired, a material applicator for applying new material. We will equip the multi-tool platform with vertical mobility by using mechanical lifts and or magnets. In the next 6 months, we plan to have the robotic arm on an intrinsically safe version of Track 1. These are just some of the tools that we will be developing in the future for the multi-tool platform. As we identify other use cases, we will also be able to develop tools for those applications.
I believe we can go as far as we want to take it. I can't settle for half measure. I want to go full out. I want to see the Alpha 1 system fully autonomous. Sort of all of these tools working together in harmony.
Wherever there's a confined space, the robotic arms can perform the work. And I think that's the exciting part, is that you can be a leader in helping to reduce injuries to humans, but yet be a leader in technology.